Hello everyone and welcome back to Netmaster Zone channel and to another video from CCNA series. In the video number 3 we speak about the connectivity, actually about the trunking port, 802.1q, native VLAN and so on. And actually there is something else here, but I didn't find that in this blueprint of Cisco, and that is VTP, VLAN Trunking Protocol. And I just decided to create a video of that to show how the VTP works, because it can be very useful and also it can be very dangerous, and it's very important to you to know how this VTP actually working, to use it actually properly. For that I just create a diagram here, and as you see that we have switch 1, switch 2 and switch 3, and also these ports are trunk. Let me write that. This port and this port is a trunk port. This is very important. This port should be trunk because as you know, the only actually trunk port can transfer the different VLANs traffic from one switch to another switch. And actually, what is VTP? VTP is used to transfer VLAN database. For example, let's assume that we need to create 100 VLANs in switch 1, and then we have to create exact 100 VLAN in switch 2 and switch 3, and it takes long time. And assume that we have 100 switches. It takes long time to go to every switches and then create this VLAN, and also it's increased the possibility of the mistake. For example, you miss one VLAN, or you just change, you create that with different number, and it will create a lot of problem in the network. And because of that, this VTP actually is designed to create VLANs and then synchronize these VLANs with other switches. Let me show you what actually status of this VTP is. For example, let me show VTP status. Here you can see that we have the version 1 or version 2, and currently it's version 1. The domain name is Cisco. I just renamed that. And also the device ID, you can see here, this is the main MAC address of the switch. Every switch has one main MAC address, and as you know that for every port it has a MAC address too. And also you can see that this is important. VTP operation mode is server. It means that when we create VLAN here, it will synchronize with others. And also the number of VLAN exists, it's by default is 5, because as you know, the VLAN 1 and the VLAN from 1001 to 1004 is the default VLAN that is already available in every switches. Show VLAN, let me show VLAN 1, and from 1002 to 1005 is the default VLAN that is available. And also if you see here that we have this is very important, the VTP revision number, this is 11, and every time when I create a VLAN, this revision number will increment by 1, and the highest configuration revision actually will apply to all these switches. It doesn't matter if this switch is in the client mode or in the server mode. The highest revision number will apply to all these switches. For example, let's go to this switch and also check here, show VTP status, and you can see here the by default the VTP mode is in the server mode. And if I go to switch 3, same. Oh, sorry. Show VTP status, and here you can see also the VTP mode is server, and all of them, all the revision number 11 here. And in this switch also, it means that they are in the sync. And let's do something. Let's create a VLAN in switch 1 and check if it's created to other VLANs also. Conf t, and then create VLAN 10, then name it IT, for example, and then VLAN 20 and name it HR. And now let's go to other switches and check if this VLAN is created. Show VLAN. You can see that this 2 VLAN is created in switch 2 and it should be in switch 3 also. Show VLAN. This 2 VLAN with the name actually is created in this switch 3 also. And now if I check the revision number, you can see show VTP status, and here the revision number for this one is 15, and do show VTP status, and this is 15 also. Every time when you create a VLAN and do any change in the VTP, it just increment the VTP status by 1. Okay, let's do something now. Every switch, if I create, for example, here a VLAN conf and VLAN 40 and name it, for example, finance. And here you can see that this VLAN is created. Show VLAN. The finance is created here, and also do show VLAN. You can see that, okay, the finance is created here also. Now actually we want to do something. We want to have one of the switch as a server and the other switch should be client. It doesn't mean actually we just limited the creation of the VLAN in other switches, because we don't want to everyone just go to a switch and create a VLAN and that VLAN will propagate it to all network and create a problem for us. And because of that we can do something. We can actually change the VTP mode. For example, here the VTP mode is server. It's okay. Let's go to this to switch and change the VTP mode to client. Conf t and VTP mode client. Now this VTP is changed, and do show VTP status. You can see that the revision number is also changed, and also the VTP mode is client now. And let's go here and make this one is as a client also. VTP mode client, and now do show VTP status, and you can see this become client, and also the revision number is updated. Now if I create a VLAN here, for example, I'm going to create VLAN 30 and name it, for example, HQ. And now let's check if this VLAN is created here. Do show VLAN, and you can see that VLAN 30 with the name of HQ is created here, and do show VLAN. It should be also in switch 3. Now let's try to create a VLAN in the VTP client and see what will happen. VLAN, for example, 50. You can see that the VTP configuration is not allowed when you device in the client mode. It means that you cannot create any VLAN in the client mode. Then easily actually you control the creation of VLAN in the every switches. Just you put one switch as a server and then create a VLAN in that switch, and that switch will actually propagate that VLAN to all other switches. But we also, let me see, VTP status. No, let's go VTP mode. In VTP mode you can see that we have server, by default is server, client that we already create these two switches as a client, and we have another option here, and that is VTP transparent mode. Actually, what the VTP transparent mode do? The VTP transparent mode, it's just transferring the VLAN information from one switch to another switch, but it doesn't update its VLAN database. For example, if I change the VTP mode here in switch 2 as a transparent, VTP mode transparent, now the VTP is in the transparent mode. It means that if any VLAN created in this switch, it will not be affected the database in switch 2. For example, let me create a VLAN 60, and you can see that the do show VLAN, this VLAN 60 is not created here, And if I check the switch 3, the VLAN 60 should be here. Do show VLAN, and the VLAN 60 is actually created here in this switch. It means that the transparent mode just transferring the VTP information from one switch to another switch, and it doesn't change anything on its own database. Let's and also let me see what else that actually in the VTP we have. If I click the VTP, you can see the domain. We can change the domain name, and we already create the domain name as a Cisco. We can change that to, for example, for NMZ, and VTP, sorry, domain name NMZ. And now the domain is changed to NMZ, and you can see that it just give me a mismatch because in other switches the VTP domain is Cisco. Let's change for this one also. VTP domain NMZ, and also let's do it here, VTP domain NMZ. Now we have the same domain here. Let's see what else we actually have in the VTP. We have VTP version. We can change the version 1 and version 2, and the difference between these two is the supporting of the number of VLANs. Actually, the version 1 is supporting only the standard VLAN, and version 2 also support the extended VLAN. We have from VLAN 1 to VLAN 100 as a 1001 as a standard VLAN, but for the extended VLAN we can create more than 1000 VLAN actually in the switch. We are not going to speak about that, but this version, actually version 2, is supporting the extended VLAN also. And one more thing that we have is the VTP password. This is very important to give a password to VTP. Let me show you why. Let's actually connect another switch to these switches. I'm going to bring a switch here, and let me this, and let me go to this switch and check the VTP status of this switch. Let's first check the VTP status in the switch 1. Show VTP status. You can see that we have the configuration revision 0 here now. Let's do something. Okay, it's good. Let me go to switch 3 and to switch 3 and show VTP status. And here the configuration revision is reset to 0. Let me, because actually I changed the VTP domain, then the configuration revision is changed to 0. Let's conf t, and here let's give a host name, switch 4, and now let's go to the VTP domain NMZ, and do show VTP status. Do show VTP status. And here you can see that the configuration revision is 0. Let's create a VLAN here. For example, conf t, I'm going to create VLAN, for example, 100 here. And let's exit from that, do show VLAN. Now VLAN 100 is created, and let's see the VTP status. Do show VTP status. Now the configuration revision is 1, and if I check here, show VTP, show VLAN, and here you can see that we have this VLANs here, VLAN 10, 20, 30, 40, and 60. Okay, let's connect this switch 3 that I just created now. Let's rename that to switch, this one is 4. Let's connect this switch to one of this port, to any of the switches. Let's connect that to this switch. We have a 3 gigabit port here, and now let's go to this switch and change the this port as a trunk. Conf t interface gigabit 0 by 1 switch port mode trunk. It's very important that the port should be in trunk mode because we are going to transfer the VLAN. And also interface gigabit 0x1 and switch port mode trunk. Now this port is trunk, and let's go to switch 4 and wait for this. Do show VLAN. You can see that I have VLAN 100 here, and do show VTP status, and the configuration revision is 1. Let's wait for this to come up. Okay, this switch now is come up. Now let's go to one of the switches, not the transparent one. Switch 2 is transparent, that we just make it transparent, and let's go here and show VLAN. You can see that all the VLANs from switch 1 is deleted, and only VLAN 100 is created here, because this one has a configuration revision of 1, and this configuration revision here was 0. Before we check that, the configuration revision was 0, and this one is 1, and now, and also this VTP was in the server mode, and then all this VLAN database is actually just overwritten, and now we only have VLAN 100 here. And if I check that here in this switch, it should be same. Show VLAN, and now I only have VLAN 100. And this is a very dangerous actually. For example, if you have an old switch in the stock, and one day you need that, and just bring it and connect that to your network. Everything is same, and switch is in the server mode, and the different VLAN actually is created in that switch, but it has a higher configuration revision in compared to your switches inside the network. In this case, this configuration of this switch, the VLAN database of this switch, will override to all the network, and it may be 100 switches. All of them will change the VLAN database according to this one, and you will lose your main VLANs in the switches, and all your network will be down. This is very important to make sure before you're connecting the switch to the network, to actually clean everything on that. It should be the configuration revision 0, because of course the other switches will have a higher configuration revision and will override this switch, not this switch override the others. But if we check in VLAN, switch 2, do show VLAN, because this one was in the transparent mode, it doesn't change anything in its VLAN database. The good thing about the transparent is this, and the good practice is to just create your VLAN, make all your switches as a client, then create one of them as a server, then create your VLAN on this, and then it will overwrite all this VLAN database to other switches. Then you can put your switches as a transparent mode. In this case, that when you connect any other switches, because they are transparent mode, they never change on the bring any change on the VLAN database. Or you can use the VTP password. Let's do this actually. As I show you that we have an option here as a VTP password, conft and VTP password. For example, let's select Cisco as a password. Now the device is encrypted, the database VLAN encrypted with password of Cisco. And now if I go to other switches, for example in switch 3, and if I just try to create a VLAN here, for example VLAN 200, and you can see that this database will not be updated here. Show VLAN. You can see that we don't have VLAN 200 here, because that this VTP has a password. And even if I change anything in this one, for example, let me create VLAN 10. I want to make the this revision, the configuration revision higher than others. VLAN 20, VLAN 30, VLAN 50, 40, VLAN 50, and do show VLAN. you can see that I just created all this VLAN here, and this is switch 4, this switch. Now if I go to switch 3, it should be updated. Show VLAN. You can see that all this VLAN is created here, but if I go to switch 1, there is no VLAN actually created here. Do show VLAN, show VLAN, and you can see that I have only VLAN 100. The good thing is to actually change the put a password on the VTP, and but still there is a it may be a problem, because the old switch may have the same password, and in this case again it will overwrite all the VLAN database to other switches. And because of that, the good practice is, as I said, to change this VTP mode to transparent after you create all your required VLAN, and then this switch will be in transparent mode, and it will never change its VLAN databases. And every time you require the VLAN, for example, at the first, of course, you may need to create all your VLANs, but in the future you may need another VLAN, and you can create that here. For example, VLAN 300 here, and now do show VLAN. You can see that 300 is created. It means that in the transparent mode we can create VLAN, and actually this because it's transparent, it never sends its information, the VLAN database, to other switches, and the other switches doesn't update themselves as according to the VLAN database of this transparent switch. Do show VTP status, and you can see that the configuration revision of this is always 0. Okay, I think I said everything about the VTP, and VTP is a protocol to synchronize the VLAN database between switches, because it may be required to create 100 VLANs in the whole network, and now it takes some time, and also it increases the possibility of the mistake to the creating this VLAN, the VLAN number, the VLAN name, and so on. And because of that, the good practice is to put one of the switches as a server and create all the VLAN on this switch, and then the switch will be transferred in its all VLAN database to other switches. And also to make sure that when you connect the old switch to a network, and that may have a higher configuration revision than other switches, because it's old, it already have some configuration, and because of that, then if you connect that to the network, and that switch be in the server mode, then it will send all its database information to all other switches, and all the network will be down in just a second. Okay, thank you for watching, and please subscribe our channel and follow us for the future video.